show that the product of the perpendicular distance from the point alpha comma beta to the pair of straight lines ax square plus 2hxy plus by square equal to 0 is modulus alpha a alpha square plus 2h alpha beta plus b beta square root of divided by root of a minus b whole square plus 4h square. Given the equation of pair of line is ax square plus 2hxy plus by square equal to 0. Divide the equation by b, we will get a by b, right? Each and every term we are doing division, right, by b. A by b x square plus 2h by b xy plus y square. B by b 1, that is y, plus y square equal to 0, right? That is equation number 1. Let y is equal to m1x, and this implies y minus m1x is equal to 0, that is equation number 2, and y is equal to m2x, that is y minus m2x is equal to 0, that is equation number 3, are the two lines with slope m1 m2 and passes through the origin such that y minus m1x into y minus m2x, which is equal to a by b x square plus 2h by b xy plus y square. That means the combination of two individual straight line which gives the pair of line. So here ax square plus 2hxy plus by square equal to 0 is represent a pair of lines, right? So in that we are taking those two lines equations are y minus m1x is equal to 0 and y minus m2x is equal to 0. So that is why the product of y minus m1x into y minus m2x, which is equal to that ax square plus 2hxy plus by square is nothing but a by b x square plus 2h by b xy plus y square. So I am multiplying y square minus m1 minus m2 minus into minus plus m1 m2x square minus m1xy then minus m2xy then y into y square, right? So that is already there. So we are grouping that one y square, right? That term is separate. Then m1 m2 x square, right? That term is separate, and minus m1 minus m2 xy is common, take it outside, minus m1 plus m2 into xy on the left hand side. Right hand side as it is, a by b x square plus 2h by b xy plus y square, right? Now equating the corresponding coefficients. So x square coefficient on the left hand side m1 m2, on the right hand side a by b. So m1 m2 is equal to a by b, and xy coefficient on the left hand side minus m1 plus m2, on the right hand side 2h by b. So minus m1 m2 is equal to 2h by b. So multiplying with minus, you will get m1 plus m2 is equal to minus 2h by b. That is fourth equation. We know that the perpendicular distance from x1 y1 to the line ax plus by plus c equal to 0 is, the formula is modulus ax1 plus by1 plus c divided by root of a square plus b square. So the perpendicular distance from the point alpha beta, instead of x1 yn we are taking alpha beta, to the line, to second line y is equal to m1 x is equal to 0 is, we are replacing, right? Instead of a we are having minus m1, so minus m1, instead of x1 we are having alpha, minus m1 alpha plus next b. So y coefficient, y minus m1 x is equal to 0, y coefficient is 1, so 1 into then y1, that is beta, there is no c value 0, plus 0 divided by root of m minus m1 square plus 1 square. So that is equal to minus m1 alpha plus beta by root of 1 plus m1 square, that is equation number 5. Similarly, the perpendicular distance from the point alpha beta to the second line, that is y minus m2x is equal to 0, that is equation number 3, is minus m2x by m2 alpha, replace m1 by m2, the previous equation, right? So you will get the same, minus m2 alpha plus 1 into beta plus 0 by minus root of minus m2 square plus 1 square, that is equal to modulus minus m2 alpha plus beta by root of 1 plus m2 square, that is equation number 6. So the product of perpendicular distance, so we are multiplying both right? So we will get, so multiplying both minus m1 alpha plus beta by root of 1 plus m1 square into minus m2 alpha plus beta by 1 plus m2 square. So multiplying numerator minus m1 alpha into minus m2 alpha, m1 m2 alpha square. Then beta into beta, beta square, minus m1 alpha into beta, similarly beta into minus m2 alpha, right, divided by root of multiplying denominator 1 into m2 square, 1 into m1 square, so 1 into 1, then m1 square into m2 square, right, that is equal to m1 m2 alpha square plus beta square. So common alpha beta minus alpha beta is common, take it outside, minus m1 plus m2 alpha beta divided by, so in the denominator we can write it as, so m1 square plus m2 square can be written as m1 plus m2 the whole square minus 2 m1 m2, a plus b whole square, a square plus b square can be written as a plus b whole square minus 2ab. So we are using that formula for that. Then remaining term plus 1 plus m1 square m2 square, right? So that is equal to, so m1 m2 value we know from 4, a by b alpha square plus beta square. Then m1 plus m2 minus 2h by b minus 2h by b alpha beta divided by root of m1 plus m2 minus 2h by b the whole square minus m1 m2 a by b minus 2 into a by b plus 1 plus m1 m2 the whole square, a by b the whole square, right, that is equal to 1 by b. 1 by b is common, that is LCM, common LCM, take it outside. So a alpha square, so there is no LCM in beta square term, so b into beta square plus 2h alpha beta divided by root of 4h square by b square minus 2a by b plus 1 plus a square by plus b square, a square by b square. So that is equal to 1 by b a alpha square plus b beta square plus 2h alpha beta divided by, in the denominator we are taking b square as LCM, common LCM, so 1 by b square within square root, right, first term 4h square, but in the second term you are having b in the denominator, but we need b square, so multiplying with b minus 2ab plus, there is no denominator for 1, so 1 into b square plus b square plus a square, right, taking so numerator as it is, in the denominator we are taking 1 by b square outside the square root, it will become 1 by b root of 4h square. So this term, remaining term, a square plus b square minus 2ab, formula is a minus b the whole square. So 1 by b in the numerator, 1 by b in the denominator get cancelled. So numerator a alpha square plus b beta square plus 2h alpha beta divided by root of 4h square plus a minus b the whole square, which is to be proved. Thanks.